Hey, Econ students, welcome to video 3.3. We're talking about long-run production costs. The key here is to remember that in the long run, all inputs, all resources, all costs become variable costs. We no longer have fixed costs because everything can change in a long enough timeline. So let's get into it. So first, in the long run, all resources are variable resources because even something as fixed in the short run as the amount that you have the capacity to produce, plant capacity, or the land that you're producing on, or the capital that you have access to, all those things can change in a long enough timeline, right? Businesses grow, get larger and larger and larger, and businesses shrink as well on a long timeline. So all of those things that we hold constant or fixed in the short run absolutely change in the long run. For example, businesses are always trying to answer this question: what plant capacity or plant size will result in the lowest per unit production costs, right? The lowest per cost. That's what I want because I want to be able to sell each unit for a certain price, have the cost be lower and lower and lower, and that chunk in the middle, my profitability. So I want to push those per unit costs as low as possible. So let's say a business doubles its resources to produce bicycles, doubles them, doubles everything, plant capacity, doubles machinery, doubles the resources that they have. What's going to happen? Well, there are three possible outcomes, which we'll show you on a graph here in a second. Outcome number one is that you double your resources, you double the production of bikes, right? It's a one-to-one. Every new resources equals one new bicycle. The other is you can more than double, right? I could double my resources, and by doing that, trigger some mass production techniques, some specialization that allows me to be more productive than I would have been otherwise, right? So I become more efficient. With one additional resource, for example, I could produce two more bikes, or four more bikes, or 10 more bikes, depending on what I'm triggering. And then finally, it could less than double. By doubling my resources, I could actually, for some reason, trigger harmful practices that could reduce my production and cause my per unit costs to rise, right? So these three stages can actually be identified on a long run average total cost curve. All right, but first we have to talk about the economies of scale. What are the economies of scale? This is a fancy phrase for saying at a certain point, businesses can actually produce at a much lower per unit cost because they're using mass production and specialization techniques that lower those per unit costs. This is why it's hard for a mom and pop shop to compete against Walmart. When Walmart is negotiating milk prices with their milk suppliers, they're buying millions and millions and millions of gallons. When a mom and pop store is buying it, they might be buying 20, 30 gallons. So Walmart can push those per unit costs way, way down because the supplier is willing to make a deal to sell 50,000, 100,000 gallons of milk. Whereas a mom and pop shop, a corner store, doesn't have that same negotiating power. And so their per unit costs are going to be higher. That's why when you go to a small business, often more expensive than one of those big box stores. So we call this: the larger the firm, generally speaking, the lower the per unit cost or the lower the average total cost. Why? Because those big businesses can utilize mass production techniques and specialization that smaller firms just don't have the capability of doing. Right? I don't know if you've ever tried to buy like t-shirts for a club or something like that. When you go to buy t-shirts, if you're buying just one, you might be paying $30 for a t-shirt. But if you buy 10,000, they give you a discount and you could be paying $10 per t-shirt. Same idea applies to these large firms, right? When they're implementing mass production techniques and they're investing in this incredible technology and this machinery, they're going to be able to push those per unit costs way, way down. For example, a car company that only makes 50 cars is going to have a high average cost per car because they're going to take that total cost and divide it by a low quantity. So they still need a factory to build them. They still need to employ people to build them. They still need some machinery to build them, but they're dividing all of those costs by just a few cars. So the per unit cost is going to be really, really high. But a firm that's producing 100,000 cars in a year, they're going to have much, much lower per unit costs. Sure, their total costs are going to be higher, right? They're making 100,000 cars. They have to employ a bunch more people. They have to have more machinery. They have to have more factories. They have to have more inputs. They need all of those things. So the total cost is going to be really, really high. But they're dividing that by 100,000 cars. And so they're actually going to have a lower average total cost because of their mass production techniques, because they can negotiate lower prices, because they're able to buy the best machinery that is the most efficient, which lowers costs on each additional unit, right? We call all of that the economies of scale. Scale is the size. The larger the size, the better your economies. Or the larger the size, the lower your average total cost. Now let's look at this on a graph. What we're going to demonstrate here is something called the long run average total cost. What this shows is on a long timeline what actually happens to cost. There are three stages of returns or three stages of cost that will occur over a long enough timeline as a firm gets bigger and bigger and bigger. So notice on our y-axis we have our costs. On our x-axis we have the quantity of cars being produced. And as we produce more and more cars, you're going to see a certain trend. So the larger something gets, the costs are going to change. That's the key relationship here, the cost relative to the quantity. So we're going to show this with a bunch of short run cost curves first. It should look familiar to you. Got your marginal cost curve here, got your average total cost, you got it intersecting at the minimum point right there. But when this firm is producing one unit, their average total cost, according to this graph, is $9,900,000. Insane, right? That's unbelievable, but they can only divide that amount by one car. So the average total cost is astronomical. Why? Well, they probably bought a factory and they're employing a bunch of people and they had to get all the machinery and all of this stuff drove up the cost, but they only produce one car, so the per unit cost is unbelievably high and they're going to lose a ton of money on that. But as they scale up, as they get larger, right, economies of scale, you're going to see the average total cost fall. So when they produce 100 cars, they're able to pull that cost down to about $50,000. So we have another average, short run average total cost here, $50,000. Why? Well, they are producing more cars, so they're able to kick in some mass production techniques, right? We call this the economies of scale. The long run average total cost is going to fall at first because mass production techniques are being used. So they're doing an assembly line, for example. They're using machinery, for example. They have standardized interchangeable parts, right? All of these things make them more efficient and push down their per unit cost. Sure, their total cost might be higher, but their per unit costs are going to be lower. Now, when they crank it up to 1,000 cars, they might lower that cost all the way down to $6,000 per car. Why? Well, they have the same machinery, but they have their assembly line, they have great capital, they have an efficient workforce that's well trained, right? They're buying all these parts and are able to negotiate lower prices because they're buying 1,000 each time they buy something. All of that pushes down their average total cost. Again, economies of scale as the business gets bigger, the per unit costs are falling. Now, let's say when they go from 1,000 to 100,000, it stays at $6,000. What happened? We call this the constant returns to scale range. The long run average total cost is as low as it can get. So they can scale up all they want from 1,000 to 100,000. They're scaling up much, much bigger, but they're not getting any more economies of scale. They already have the best mass production techniques. They already have the best assembly line. They already have the best costs on their parts. All of those things that impact your per unit costs are relatively constant over the course of scaling up from 1,000 cars to 100,000 cars. So that's the constant returns to scale range. And then finally, I'll get my face out of the way. Finally, when you get to maybe 1,000,000 cars, you start to see that rise back up to $50,000. Why would that happen? Well, we call this the diseconomies of scale. The business is too big. The firm is too large. And so now they have too much to manage. They're paying a bunch of management to run the show. They have, they might be getting lawsuits because they're so large, right? There are many, many additional costs because they're too big and too difficult to manage. So the average total cost rises as a result. We call this rising costs at the end when a firm is too big, the diseconomies of scale. So put it all together, and that's your long run average total cost there, right? So this, you connect the dots. That's your long run average total cost. Now, the good news is you don't have to know all of these short run cost curves. We did this just to demonstrate what happens as a firm gets bigger and bigger and bigger. So I can strip all of that away and it looks like this. We label it LRATC, or long run average total cost. And you can identify the three ranges. The first range is the economies of scale. Economies of scale are the average total costs are falling as a firm gets larger and larger because, as you can see here, it's falling as a firm gets larger and larger because they're implementing mass production techniques. Next range is our cost of returns to scale. This is when it bottoms out, it flatlines, right? Meaning that they're producing at the most efficient level. The mass production techniques are as good as it can get, the lowest possible cost. And then finally, you have your third range, which is your diseconomies of scale. We recognize this as the long run average total cost curve starts to rise because the firm's getting too big and there's all kinds of additional management costs as a result. Know those three ranges and you will actually be in very good shape. Looks just like this. You oftentimes will see this and will be asked to calculate, or not calculate, sorry, identify each of the three ranges. That's your LRATC. Again, recognize that as quantity goes up, initially average total costs are going to fall or per unit costs are going to fall. Then they bottom out because you have your best mass production techniques, and then you get too big and they scale up. Okay, now keep in mind that the long run or the law of diminishing returns does not apply in the long run because there are no fixed resources. So this is not caused by the law of diminishing returns. That's from the production function. Production function absolutely shows that diminishing returns, right? You have increasing returns, diminishing returns, and then negative returns with that little swoop, right? You remember that. This is not caused by that, right? Remember, law of diminishing returns is when you add variable resources to a fixed resource. In this case, all resources are variable. What's happening here is economies of scale. Is as a firm gets bigger and bigger, they can implement mass production techniques and specialization, which lowers the average cost. It bottoms out in the middle, and then it starts to rise as a firm gets too large. Okay, little test question for you there. F&D manufacturing company increases all its inputs by 50% each. If F&D's output increased by 100%, then F&D is experiencing A is your correct answer, increasing returns to scale or economies of scale, right? Same thing, increasing returns to scale or economies of scale. In other words, by increasing the resources by 50%, they're having a greater increase in productivity. That you take that same resource cost divided by a larger quantity, that's going to be shown as LRATC going down. When your inputs are less than your outputs, you got economies of scale. It would be constant if it was 100% and 100%. If I increase all my resources by 100% and I get 100% out. So one new input equals one new bicycle. And there would be diseconomies of scale if I increase one resource and I have half a bicycle as a result. Okay, cool, cool, cool. If that made sense to you, jump over and take the Khan Academy for long run production costs, and I will see you in class. Peace.